Welcome back. Next, I want to refer all of us to 7.1 of your notes. I'm going to cover some basic results. I'll produce the results here and then I'll give a simple example and I'm quite sure you'll get it. Let's look at the first one. Suppose I have this one. Sorry, let me change the ink color of my ink. Suppose I have something like that. R square R equals to 9 and 215. Now you should know, if you have done your quiz correctly, this one is quite obvious. It's actually 9 square plus 10 square all the way to 15 square. Right. Sometimes it may be necessary to express this summation, this kind of summation, let's say start from m, which is 9 in this case, it as a difference of two summation. That means you want to express this as a difference of something from r equals to 1 minus r equals to 1 r squared. Now the question is, it's quite obvious that if I write it like that, if I write this, it is 1 square plus 2 square plus 3 square all the way to 15 square. To get this summation, which is starting from 9 square, you must minus from 1 all the way to 8. Not 9, but you must minus, correct? You must minus from 1 to 8 in order to get 9 square. And therefore, this result, right? If you want to sum from m to n, is equivalent to summing from 1 to n minus summing from 1 to m minus 1. This is essentially your m minus 1. So to remember this result. Next, if suppose I have a constant k, where k is a constant, I give you a very simple example. Let's say it is 2r squared. I want to sum from r equals to 1 to 10. Now, it is the same, obviously, as factorizing the 2 out. Right? But just be careful, k must be a constant. It cannot contain a variable. What I'm saying is this, you cannot say this is r times, I don't know, sine r. R equals to 1 to 10. Now, this is not the same as factorizing. You cannot loosely factorize this like that. This is obviously wrong. So I want to emphasize k is a constant. Result number 3. Suppose you have two summation like that in a bracket. All right, I give you a quick example. Let's say r equals to 1 to 10. Correct? And you want r plus, say, 2r. Now, whether you write it as 1 plus 2 to the power 1 plus 2 plus 2 to the power 2 plus 3 plus 2 to the power 3, blah, blah, blah. Now, you can actually group 1, 2, 3 together, correct? And you will actually get this thing. You can split up the summation and say this is r plus 10 to r. So no matter what is the expression for u, r, vr, you can, in inverted commas, split up the summation. Now, of course, I don't think I want to illustrate the minus. It is quite simple. If you look at the result from 2 to 3, because you have a constant a and b, if a and b are constants, you can factorize the a and also split up the summation like that. One very important result here that you cannot, just because a summation has a multiplication, you cannot split up it like that. I'll give you a simple example. Let's say you have r times 2r, like that. You cannot simply say this is r equals to 1, 10 times. Because the expression, if you write it out, don't believe you try, you write it out. You write the 10 terms here, you write 10 terms here. You have 10 terms times 10 terms, you will get 100 terms. When actually here, you only have 10 terms and they are not the same. I want to produce some standard results for all of us to refer to. I don't think you need to memorize. If you understand, you shouldn't have any problems with this. First standard result. Follow me very closely. If you substitute r equals to 1 into c, you will still get a c. Next term r equals to 2 into c, you will still get another c. How many c's do you have? Right? You will actually get a lot of c's. Actually, you will get n c's. Correct? You get c times n. So first result, if this is a constant here, this is the variable and this is a constant, actually you just c plus c plus c and you have n times. Next, this one. If you write it out, this is 1 plus 2 plus 3 all the way to n. Now, if you have learned your previous chapter properly, chapter 6, arithmetic progression, you can tell that this is a AP. First term 1, last term n, number of terms n. So I will write it out. This is an AP with first term equals to 1, last term is n, number of terms also n. So actually it's first term plus last term, n over 2, first term plus last term. Okay, go and revise your AP if you are not clear. Now, what about this? Actually, this is similar to this in that this is also an AP where this is m plus 1 all the way to n. Now, this is also AP, common difference 1. The only difference here is that the number of terms is no longer n. The number of terms is n minus m plus 1. Okay, I repeat, number of terms is n minus m plus 1. So actually, it is, it is actually n minus m plus 1 divided by 2, first term plus last term, m plus n. Let us take a look at this one. If you understood summation sign properly so far, you will know that this is a to the power 1. Right? You substitute r equals to 1 into this general expression, you get a to the power 1, a square, a cube, all the way to a to the power n. Now this one is a general progression. It's a GP. If you learn your previous chapter properly, it's a GP with first term equals to a. Common ratio is also a. Number of terms is n. Therefore, this one will just be a 1 minus a to the power n, 1 minus a. Do you need to memorize? I don't think so. Right? If you really understood what you have learned from APGP so far, this should be quite standard. We'll move on to short quiz, then we'll come back. Thank you.